Good morning, friends. Today we'll discuss about some competitive problems in AC circuits. In the first problem, it is given as the percentage error of power is being asked. Therefore, the percentage error of the voltage is given as 2.5 according to the problem. So here the rating is given between 220 volts to that is 100 watts. So that is the power rating they have given us. Therefore, we have to calculate the change in power, that is the power percentage, how much there is an error in the power we are going to discuss. That is what del P by P. So we have to calculate it. So we know the power ratings formula. So percentage error we already discussed in the 11th standard. The same formula. The formula is power is given as V squared by R. So when I am substituting here del P by P equals, so when your percentage error is del P by P into 100 equals 2 into del V by V into 100. So that is the percentage error formula. So 2 into del V by V is given as 2.5 into percentage is 100. So it is 2 into 2.5 is nothing but, therefore del P by P equal to 5%. So the option A is correct. This is the first problem we have discussed. And the second problem, they are asking you to find the RMS value of the current. The inductor value is given as 70 millihenry and the voltage is 220 volts and the frequency is 50 hertz. So according to the problem, the inductor coil is 70 millihertz, which is nothing but 70 into 10 power minus 3 hertz. Voltage is given as 220 volt and the frequency nu is given as 50 hertz. That is the AC power supply. So first you write what is given. Then we have to calculate what is being asked. Therefore, they are asking about the RMS value of the current. So therefore, the inductive reactance formula is XL equal to omega L. So omega I write it as 2 pi nu. That is nothing but 2 pi nu L. Therefore, XL equals. Now I am going to substitute all the values. 2 into pi is 3.14 into nu is 50 hertz. So 50 into L is 70 millihenry, that is into 70 into 10 power minus 3. So when I am multiplying all these things, so I multiply all this, I am not showing, I am skipping it off. When I multiply it, we get XL is equal to 21.99 ohms, which is approximately equals 22 ohms. So I got the value for XL. Now they are asked the RMS value. Therefore IRMS is given by the formula. IRMS is equal to, that is I is equal to V by R. So it is V by R, instead of R I take it as XL because it is an inductor coil. So inductive reactance I am using. So it is 220 by 22. When I am cancelling it off, you will get it as 10 volt. So IRMS equals 10 volt. So when I check it over, the option is C option is correct. Sorry, B option is correct. So this is how we have to solve it. The next problem is, they are given us two variables X and Y, and also they are asking to find out if X and Y are connected in series, what could be the RMS value. That's what they are given. The given voltage is given as 100 volt. The current flowing through this is 5 ampere. So the phase shift CD is already given as 90 degrees. So it is 5 by 2. Now when I am checking the question, you can see that X is connected to it. So X is in phase with the current, that is in this X circuit it is in phase. So when you are telling the voltage and current are in phase, it should be a resistor. So I wrote it as a resistor. Therefore R is equals V by I or V0 by I0. So it is nothing but 100 by 5. Therefore R is equal to, it is 20 ohms. That is the exact. So since they are in phase, it should be only a resistor. So the value is 20 ohms. Now I am going for the Y network. So they are connecting the Y component to it. So when I am reading it, you can see that the current lags behind the voltage by pi by 2. So the current lags behind it by pi by 2. If the current is lagging, there is only one component, which is nothing but an inductor. So Y must be an inductor as per the question. So Y is an inductor. When I am substituting it, so that is the important point you have to keep in your mind. Now I am going to calculate the inductive reactance. It is given by XL is equal to the same formula, voltage by current. So V equal to IR, the same formula I am using it. So V naught by I naught, which is nothing but 100 by 5. So once again it is 20 ohms. So individual resistance, that is R is equal to 20 ohms and the inductive reactance is 20 ohms. Now as per the problem, they are asking, they are connecting it them in series. So I'm going to connect both of the networks in series and I'm going to check what will be the RMS value of current in both of them. So I'm just drawing the circuit. They are in series. So as per the problem, it has been given. Now I'm going to draw the circuit. So first I'm taken resistor, then an inductor. It is connected to an constant power supply of AC voltage. So X and Y I take it over. Next the values I am writing. R is equal to 20 ohms and XL equal to 20 ohms. Now they both are connected in series. So the impedance formula is given as that is equal to root of R squared plus XL square. So for inductor and resistor I am using the formula. Therefore that is equal to, I am substituting it. So it is R is 20 square plus XL is 20 square. So it is 20 plus 20, 2 times of 20 square. So 20 root 2 will be the answer. So the impedance value set is given as 20 root 2 ohms. So now I calculated the impedance. The next part is we have to find out what will be the RMS value. So I have come till now we have calculated the impedance. The next one is we have to calculate the IRMS as per the problem. So IRMS is equal to VRMS by the resistance or the impedance Z. So V naught by the impedance value Z is given as times of root 2. So V0 by root 2. VRMS equal to V0 by root 2 by Z. So it is 100 by root 2 into Z value is 20 root 2. So the Z value is 20 root 2. So root 2 into root 2 gives, it is nothing but 2 into 20 is 40. So 100 by 40. So when I am cancelling it off, you will get it as it is 5 by 2 amperes. So when I am checking the problem, it is 5 by 2 amperes. So when I check out the answer for that particular question, it is the D option. So that is the answer. So first you have to calculate. So step by step you need to proceed. The next problem we are discussing is about a capacitor, and they are asking to find about the RMS value of the current delivered by the capacitor. The capacitance value is given as 100 microfarad. So it is 100 into 10 power minus 6 farad. Therefore the voltage level is given as 100 volt. I entered it. They are asking the RMS value, and also the frequency has been given, it is 50 Hertz. So first you write what is given first. Then the capacitive reactance is given by the formula 1 by omega c, which is nothing but 1 by omega is 2 pi nu into c. That is 2 pi into frequency into c. Now I am substituting the values for them, which is nothing but therefore xc is equals 1 divided by 2 into 3.14 into the frequency is given as 50 into the c value is given as 100 into 10 power minus 6. I am skipping out the calculation part. I am directly moving to the answer. Therefore xc will be given as, when I am substituting it, you will be getting the value as 3.18 into 10 power 1. So when I am substituting it will be 31.84 or something it is coming. So 31.84 ohms. That is the capacitive reactance I have calculated. The next thing is, we are asked to find out the RMS value. So IRMS is equal to voltage by resistance. So V by XC. So IRMS equal to voltages given here as 100 divided by XC we calculate as 31.84. So when I am substituting at 100 by 31.84 I am substituting. So when I am cancelling it off, 100 divided by 31.84, I get IRMS equals 3.14. So it is 3.14 amperes. So when I check out the answer, it is subdivision A is the answer for it. So first you start with what is given. The next problem is, we have to enter what is the values given here. First you write down the given part. So here the first value, the resistance is given as, the voltage is given as 20 volt. The voltage is given as 12 volt. Therefore, the voltage across resistor and is given as the voltage V is equal to root of VR squared plus VL square. So I am just entering what is the values given. So now I am calculating substitute the values. Therefore V is equals root of VR squared plus VL squared. So I am squaring it off to simplify the problem. So therefore V squared is equal to VR squared plus VL square. So we can also keep it as a root. I am expanding it up. Therefore V square equals VR square is V squared plus VL square. I am going to substitute here. So just VL square is equal to V squared minus VR square. Just I am rearranging the term because VL square had to be calculated. Therefore VL square equals 20 square plus, so 20 square minus 12 square. So I get it as VL square equals 20 square is 400 minus 12 squared is 144. I am subtracting them. So get it as 256. So VL is equal to root of 256. So VL is equal to 16 ohms. 16 volt. So VL is equal to 16 volt. So when I am checking the answer, it is nothing but the A subdivision. So when I am checking the question, the voltage value is A subdivision. So the second part is upcoming. So we will be discussing 5 more problems in the second part. Thank you.